All right, let's dive in. Looks like we're going deep on space exploration and astronomy today.
Always a fascinating topic.
Definitely. What's interesting to me is just glancing at this script, The Wonders of Space Exploration and Astronomy, it seems like astronomy is kind of woven into, like, all of human history.
Oh, absolutely. Yeah. It's really striking when you start to look at it, just how much astronomy has influenced us.
Okay, so, we've got the Babylonians, the Egyptians, the Greeks, all these ancient civilizations. What, like, jumps out at you about their observations? I mean, they didn't exactly have, the Hubble telescope.
Right. It's easy to forget how much they accomplished without modern tools. I mean, they were incredibly sophisticated, these civilizations. Think about it. They used the stars for navigation,
Oh, yeah.
developed these complex calendars. They even predicted eclipses and with pretty remarkable accuracy too.
It's pretty incredible when you think about it, like the power of just human observation and ingenuity.
Yeah, absolutely. I mean, they were laying the foundation really for how we understand the universe today, even if they didn't have the same, scientific framework that we have now.
Totally. And speaking of breakthroughs, I mean, your script mentions Galileo, and I gotta say, that story never gets old. Like, can you imagine pointing that early telescope at the sky and seeing Jupiter's moons for the first time? I mean, what was it about his discoveries that just, like, shook things up so much?
Well, it wasn't just what he saw, it was what it meant. You see, Galileo's observations, they challenged the whole idea, the prevailing idea, that everything revolved around the Earth.
Oh, yeah, the whole geocentric model.
Right. And so when he sees Jupiter's moons, well, that's evidence for a heliocentric model with the sun at the center.
Huge shift.
Yeah, it was radical.
Yeah.
And it really sparked a lot of debate, a lot of controversy.
Makes sense. It's like, whoa, the ground is shifting under our feet.
Yeah.
And, I think that's what I love about science. It can totally change how we see reality.
It's powerful.
So, okay, Galileo's rocking the boat. Your script also mentions Isaac Newton. Did Newton, like, actually build anything for space?
Well, he didn't build rockets, but he gave us the instruction manual, his laws of motion, universal gravitation. That's how we figured out, well, how anything moves in space, how to calculate trajectories, and how to escape Earth's gravity.
Ah, so he's the how guy.
Yeah, you could say that. Launching satellites, sending people to the moon, it all goes back to Newton.
Okay. So then fast forward to the 20th century, and we've got the space race. I mean, your script, it really captures, like, the energy of that time. Was it all, like, pure science, or was there more to it?
Well, there's definitely a ton of scientific ambition, no doubt, but it was also really tied up in politics. The Cold War,
Right.
I mean, when the Soviet Union launched Sputnik 1 in 57, that was huge.
Yeah. First artificial satellite.
It sent shockwaves, I think, through the U.S. Suddenly, it was like, we need to catch up. We need to be first in space.
So much pressure.
Definitely up the stakes.
I remember you mentioned Yuri Gagarin in your notes. His flight, I mean, what did that represent in the whole space race thing?
Well, Gagarin's flight, that was 61, that showed, hey, humans can not only survive up there, they can function, they can do complex stuff.
Makes sense?
It gave the Soviets this huge morale boost. And for the U.S., it was like, okay, we really got to step it up.
And they did. The Apollo program. And then, boom, 1969, moon landing. Iconic. I remember you mentioned Neil Armstrong's famous line, "One small step for man, one giant leap for mankind." I mean, does that still resonate today, or has it, kind of lost its punch?
It's a powerful statement, for sure. I mean, captured that whole sense of achievement back then. It's hard to say if it has the same impact now. I mean, we're kind of used to seeing astronauts in space these days, right?
Yeah, it's not quite as novel as it once was.
But I think Armstrong's words still remind us of what's possible, what we can accomplish when we really set our minds to something big.
Totally. It's interesting to see how our perception of space has changed over time. Now, you also mentioned the International Space Station. What does, like, the creation of the ISS tell us about, where space exploration is headed?
I think the ISS marks a real turning point. We shifted from, this fierce competition to collaboration.
Yeah.
Instead of trying to beat each other, all these countries came together to build this incredible orbiting lab. It really shows what we can do when we work together in space.
And that sets the stage for, well, everything that comes next, right?
Yeah.
So let's talk about Mars. It's been getting a lot of attention, and for good reason. I mean, your script mentioned all those amazing NASA rovers. What have we learned from these, like, robotic explorers, and why are we so fascinated by Mars in the first place?
Well, those rovers, they've been sending back just tons of data, and it's really changed how we think about Mars. Like, one of the biggest things we've learned is that there used to be water there, like a lot of it.
Ancient water, right?
Yeah, exactly. And that tells us that Mars, it might have been a much warmer, wetter place in the past, maybe even like habitable.
See, that's what gets me about Mars. It's like this giant mystery
Ah.
waiting to be solved. Like, was there life there? And your script even mentions looking for biosignatures. So break it down for us. What are biosignatures?
Well, basically, it's anything that could be a sign of life, past or present. Like on Mars, we're looking for things like certain chemicals, maybe fossilized microbes, or even like the ratios of different isotopes, stuff that's usually linked to living things.
Like fingerprints, but for life on Mars.
Exactly. And finding proof of past life on Mars, well, that would be huge. It would completely change how we see, life's potential out there in the
A
universe.
total game changer.
Yeah.
Which brings us to, well, humans going to Mars.
Mhm.
Now, you mentioned the Artemis program, that whole thing. Can you remind me, what's that all about? And how does it fit in with getting to Mars?
Yeah. So Artemis, it's a whole program, multiple phases, and the goal is to have humans living on the moon, like long term. And it's kind of seen as a practice run for Mars,
Mm,
build a base on the moon, test out all the tech, learn how to live and work in deep space, all that stuff.
makes sense. Learn to walk before you run, as they say. And it's not just NASA anymore, right? I know you were into SpaceX and Blue Origin, those private companies. What role do you see them playing?
Oh, they're shaking things up, that's for sure. I mean, they're bringing in new ideas, that entrepreneurial energy, and they're really focused on keeping costs down and their goals, like SpaceX wanting to actually colonize Mars. It's crazy ambitious, but it's pushing the boundaries of what we thought was possible.
Almost like a new space race, but with different players. Now, in your script, you mentioned interstellar travel. I mean, that's the ultimate frontier, right?
Yeah.
Traveling beyond our solar system. What are the biggest challenges there? Is it even, like, remotely possible?
Well, the biggest problem is just the sheer distance, right? Even if we could travel at the speed of light, which we can't, it would still take years to reach the nearest star system. But scientists are looking into some wild ideas for propulsion, like fusion-powered engines, or even like warp drives, although that's super theoretical.
It's mind-blowing. But even if we can't physically get to those other stars yet,
Mhm.
we do have some amazing tools to observe them, like the James Webb Space Telescope, right? You were pretty excited about that in your notes. What's so special about it? What are we learning?
The James Webb Telescope, it's just incredible, like a masterpiece of engineering. It can see in infrared light, which means it can see through those clouds of gas and dust out there in space, stuff we couldn't see before. And it's giving us these amazing views of the early universe, how stars and galaxies formed, even the atmospheres of those distant exoplanets.
Exoplanets, that's what I wanted to ask you about. In the search for life beyond Earth, what makes those exoplanets so interesting?
Well, exoplanets, those are planets orbiting other stars. And studying them, well, it gives us a chance to see all these different kinds of planetary systems. And maybe, just maybe, we can find signs of life out there. The James Webb Telescope can actually analyze their atmospheres, looking for chemicals that might hint at life.
Wow. So we could actually detect life on a planet light years away.
It's possible. It's really amazing to think about. And your script also touched on intelligent life.
Hmm.
How are scientists going about, like, looking for signals from aliens?
Right. Good point.
Well, there's this whole field called SETI, the Search for Extraterrestrial Intelligence. And basically, scientists use these huge radio telescopes to scan the skies for any kind of artificial signal, like repeating patterns or those really narrow band emissions, the kind of thing that would point to some advanced tech.
Like, hey, we're here.
Exactly. And so far, we haven't found anything conclusive, but the search goes on. And, if we did find something, well, it would change everything.
It'd be like, catching a message in a bottle, but from across the galaxy. It's a long shot, but the potential payoff is just so huge.
Exactly. It's all about pushing those boundaries, embracing the unknown. That's what drives space exploration, I think.
I love that. Wow. It's incredible to think about all that. I mean, we've covered so much ground here, from those like ancient stargazers to the possibility of like actually traveling to other stars. It's kind of mind-blowing. And one thing that really stands out to me looking back at your script is this idea of human curiosity. Like, it's this driving force behind it all.
Yeah, absolutely. I mean, I think it's like built into us, you know? We want to understand our place in the universe. We want to unravel those mysteries. And that's what keeps pushing us forward from those first maps of the stars all the way to like the most ambitious space missions we can imagine. It's all driven by that same curiosity.
It makes me think about what you were saying earlier about how the impact of the moon landing, it might have faded a bit over time.
Hmm.
So is there anything we can do to like reignite that sense of wonder
Yeah.
about space?
Well, I think it's about making space exploration feel more, I don't know, more connected to our lives. You know, make it relatable, relevant, like show off the incredible technology, the discoveries, the human stories behind it all, and also highlight how it benefits us here on Earth.
Oh yeah, that's a good point because sometimes it does feel like space is just this like distant thing.
Yeah.
But it actually affects us in so many ways. Like you mentioned in your script, satellite technology that's revolutionized communication, navigation, how we study our own planet.
Exactly. And there's probably all sorts of other tech out there just waiting to be discovered.
Yeah.
Stuff we can't even imagine yet.
It's true. And it's not JCC about the practical stuff either. There's something about space exploration that just captures the imagination. It's inspiring.
Oh, yeah. It reminds us just how vast and amazing the universe is, and it makes you think beyond, everyday life. It makes you consider our place in the grand scheme of things.
So as we wrap up this deep dive, what's the one thing you hope our listener takes away from all this? From this exploration of space exploration, I guess.
I think the biggest thing is just to remember that, this journey, it's not over. It's a journey for all of us. Every new discovery, every new technology, it brings us closer to understanding where we fit in the cosmos. So keep exploring, keep asking questions, keep dreaming. The universe is waiting.
That's a great way to put it. And on that note, I think we'll bring this deep dive to a close. But before you go, listener, I have a suggestion.